All right, guys. I want to help you today with Unit 4, Lesson 2, Square Root and Cube Root Graphs. I actually want to kind of start at the bottom of this page. This is going to work with the transformations the same way that it did in Unit 1 with your geometry graphs and in Unit 2 with your quadratic graphs. So remember that the A value in front, that is going to reflect if it is negative, and it's going to do a vertical stretch if it's greater than 1, and if it is a fraction or decimal between 0 and 1, that's going to be a vertical compression. It's going to make it wider. This makes it more narrow. This flips it upside down, and we will check this here in a moment with Desmos. Remember that the H and the K are your translations, so you're sliding up, down, left, and right. Remember that if it's in the parentheses with your X, you do the opposite of H. So if it would be minus H, we are going to move H units to the right. But then the thing outside, if that's adding, it's going to go up. If it's subtracting, it's going to go down. So the first thing that we're going to look at is the quadratic. Remember that the vertex form, the H and K, those are the coordinates of the vertex, whether it be a quadratic, cubic, square root, cubed root, whatever. The vertex is always at H, K. Now, here we don't see anything added or subtracted inside the parentheses with the X, and we do not see anything added or subtracted at the end. So that indicates that this vertex is at 0, 0. And feel free to always check with Desmos. We got y equals x squared, and you can always hit that vertex, and you can see right there that that is at 0, 0, just like we said. Hopefully you remember that the domain is the all possible inputs. It's all of the x's, and it is basically the width of the graph. And if you zoom out, you start to see that this thing gets wider forever. So we will either say that that goes, well, there's a couple ways you could say it, negative infinity to positive infinity. You could also use the symbol, the double /r for all real numbers. Either of these are telling us that our parabola is infinitely wide. Then we have the range. Remember, the range is all the output values. It's all the y's. And in terms of the graph, it goes from the bottom to the top. I would use that minimum value, or if it's upside down, maximum value. And that's going to go from your y, which is 0, all the way up forever to infinity. So our range is going to go from 0 to infinity. Remember to always put a parenthesis on infinity because you can never equal it. And wherever your actual boundary is, that should use a bracket because you can equal 0. You can see that's a point on the graph right there. Okay, so hopefully you know that to get any XY coordinates, you pick an X, you plug it in, you calculate it out, you get your Y. Or you could use Desmos and edit your list, get a table of values, and then you get all kinds of XY coordinates. So we've got -2, 4, 1, 2, 3, 4. We got -1, 1. We've got 0, 0, 1, 2, 2, 4. We've actually got 3, 9, and -3, 9. And there is our parabola. So, real quick, just to verify some of these transformations, if we have x minus h, and then we got a plus k, and then in front we have an a, and tell it to make these sliders, we can see that as, there we go, As k gets higher, the y coordinate or the y-intercept is moving up. All the y coordinates are moving up. If we bring it down, the parabola moves down. With the h, remember that is the opposite. So let me put this at 0, hopefully. There we go. If I move it to 3.7 or 4, we'll say, that's a positive 4, but that would be x minus 4. So it is the opposite there. Same thing if I move it this way, like negative 10. That would be x minus a negative 10, and we would see that as a plus 10. But that moves us to the left. And then we have our a value. If it is greater than 1, it's going to stretch it vertically, making it move upward quicker and making it more narrow. And if it is between 0 and 1, you can see it makes it wider. And if it's negative, it flips your parabola upside down. We have a square root. The square root of x, once again, there's nothing added or subtracted to that value. So the vertex here is going to be at 0, 0. And just to relate it, we're going to pull it back here. It's always good when doing your domain and range to graph something so that you can verify that it looks the way that it should. And then we're going to do y equals, and you could bring up the virtual keyboard and find the square root button, but I typically type SQRT and the square root symbol comes up, and we've got x. And then you can see they do have the same vertex. And the square root is kind of half of a sideways parabola. So this vertex is at 0, 0. When we talk about the domain, that's all the x's. So we move from left to right. That is going to go from 0 to infinity, which we will write there. And the range goes from bottom to top, and that also goes from 0 to infinity. And remember that if you need to make a table, you can do that. You can't take the square root of negative numbers. That's why the left side is not here and why this is undefined. And I would only plot the points with whole numbers. I wouldn't do the decimal ones. You can, but they're just hard to graph. So we have 0, 0. We've got 1, 1. We've got 4, 2. And then we've got 9, 3. And that is what your parabola should look like. And then, yet again, let's double check these transformation rules. So if I go and put a here, minus h, and then a plus k, and look at these sliders. You can see when we increase k, it moves up. When we make it smaller or less, it goes down. If the h value, remember that's x minus h, so minus 1 moves it right 1. Minus 2 or 3 in this case, that would be x minus 3. That moves us to the right 3. And opposite is true here. If I've got x minus a negative 4, that would be x plus 4, and the opposite of plus 4 is negative 4. And then we've got our a value, which is our vertical stretch. So if we increase this value, it stretches it up in the air. This is much easier to tell. And then if it's between 0 and 1, it's going to vertically compress or shrink it down. And if it's negative, it flips it over the x-axis. So with the x to the third power, it's best just to see that for yourself. It's basically a parabola with one of the arms bent downward. So it's kind of like maybe like an S shape. And anything with the x cubed, or really an odd number, x to the third, fifth, seventh, ninth, or anything with a cubed root, and you'll see that here in a moment, or fifth root, or seventh root, or ninth root, the domain and range will always be negative infinity to positive infinity. And here the vertex, we don't see anything added or subtracted, so that's going to be 0, 0 yet again. And to get a table, remember now, gear, table, plot the points. So negative 2, 8, negative 1, ooh, that was negative 2, negative 8, sorry. Negative 2, negative 8, negative 1, negative 1, 0, 0, positive 1, and 2, 8. So this thing should look like that. Ignore that little point there. Let's see if I can erase that guy. Hey, look, it's gone. Okay, so the final one will be the cubed root. And if I go and do, I would say CBRT will get you the cubed root of x and make a table. But if you forgot that function, you would bring up the functions menu, you would have to push this button, and you would scroll all the way down to the N with the root symbol, and you could type in any value root that you want. 3, 4, 5, 6, 7, 8, ninth root. And really what we're asking about this root is what number times itself 3 times gives us, let's say, 8. 2 times 2 is 4, times 2 is 8. So 2 times itself 3 times is 8. So the cubed root of 8 is 2. That is what is happening there. And you can see here that this also turns that S shape that is x cubed on its side, and this is going down and to the left forever and up and to the right forever. So yet again, the domain and range are negative infinity to positive infinity. And then the vertex is still at 0, 0. We don't see anything added or subtracted to those x's. So this is your main idea here. The vertex, make sure you close that parenthesis there, is the h and the k value. The a is the vertical stretch. This tells you how far left or right, how far up or down, and the vertical stretch or the reflection. That covers all of your transformations that you will see here. So when we look at this, let's go separate the two tabs, and we want to go to this one. Here we go. Okay, so this value, I'll use different highlighters. That's your x transformation. This is your y transformation. So the vertex, the opposite of negative 3 is positive 3, and this one is exactly the same. So this is the yellow, and this is the blue. If we go back to Desmos for a second, and we were to plot the point 3, 6, 3, 6, you can see to get to that point, we had to go right 3 and up 6. So that's what your shift is. We are going to go right 3 and up 6. Okay, with this one, our vertex, it's going to be the opposite of positive 1, just like this was the opposite of negative 3. So this is going to be negative 1, and there is no value added or subtracted out here. That means our y-coordinate is going to be 0. So this is going to be left 1, and there's no... There is no vertical shift up or down. On on this last one, there's nothing in parentheses with the x. Like here, there's something in parentheses with the x in there. So the number that represents nothing is 0. There is no horizontal shift. We do have -4, which is going to be exactly what we think there. And there is no horizontal shift, left or right, but there is a shift down 4 units. So I just use L for left, R for right, U for up, D for down. Those are everything that I think that you would need. I would work out some of these, and you'll have an answer key that you can check from. But it is all the same no matter if it is a quadratic, a cubic, a square root, or a cubed root. Just real quick, I'll throw out a couple more here. This one is the opposite. That's -2 and -5. We're going to have our yellow, which is our vertical shift. And we've got our blue, which is our horizontal shift. So that's going to go left 2 and down 5. If we look here, the opposite of -2 is a +2, and then this number is exactly the same, so that's going to go right 2 and up 5. And then I'll do this one that's got both numbers. That's the opposite of +2 is -2. And then this value, the vertical shift on the outside, is exactly what you would think. That's going to go left 2 and up 4. With the graphing, just make sure that you go and use Desmos. Double check your table of values, plot those points as properly as you can to make a legible graph. The better looking you make the graph, the better chance you've got of making a good grade on here. And then finally, 7 through 10. These are going to be the tricky problems. So it says, write an equation of a square root function with a vertex at that. So remember what a square root function looks like. It's, well, got the square root. It's appropriately named. And it's always going to be the opposite inside the x. So we got like y equals, or you could say f of x equals the square root of x. The opposite of -5 is +5. And then your vertical translation, is a 3. So outside of the square root, we have a +3. The equation for the square root of a function that has been translated right 10 units and up 6 units. So that puts the vertex at 10, 6. We're going to say y equals the square root of x minus 10, because it's always the opposite, minus 10, because that's a +10. This was a -5, so we did +5. And then outside of the square root, we're going to do a +6. So we got a cube root, translated left 3 units and down 2 units. So left 3 is -3 and down 2 is -2. Y equals, we're going to do the cubed root function. You do the opposite of -3, which is +3, in the grouping symbol with the x, and then your vertical translation, that y coordinate, is outside of the square root, and it is exactly what you think it is. And then finally, write the equation of a square root function that has been translated right 4 units and reflected across the x-axis. Okay, so be careful on this one. We got y equals, and it's a square root. So right 4 units is going to be 4, 0, because we didn't go up or down. They didn't specify, so that's going to be a 0. So we've got x, the opposite of 4 is -4. There's not going to be anything added or subtracted there on the end because it didn't move up or down. But we do have should have left a little bit of room there. It is reflected over the x-axis, and remember, that's just going to be a negative out front. And let's just double check this one real quick. We've got y equals negative square root of x minus 4. Notice it's flipped upside down. It is translated right 4 units, and it does what we say it's going to do. So double check with your teacher for the answer key for the rest of these. I'm not going to waste your time teaching them over and over again because they are going to be all the same. Yeah, I'll help you out with the next lesson, lesson 3, here in a moment. Good luck.